Hey everyone, today we'll finally be adding an enemy system into the game which will allow for easy and powerful enemy customization. Right at the start I'm going to go ahead and mention that I do not use behavior trees in this video. The utility AI system that I'm creating and will demonstrate in this video does in fact interact with behavior trees if you want to do it that way, but I personally am not using behavior trees in this project. I was originally using behavior trees, and there's a lot of reasons why I'm chosen against using them to continue with the project, and I don't want to go into those in this video, but maybe in a future video I'll go into more detail why I chose not to use them. But for now we will continue, and I'll demonstrate how I created the enemy pawn and then the utility AI system to control the enemies that I make in this game. The enemy pawn is a pawn, so it'll inherit all the UE4 pawn functions and functionality. I also added functions such as on lethal damage and on non-lethal damage, so we can customize what we want the enemy to do when he takes lethal damage and non-lethal damage. There's also this take bullet damage function which we use when we want to apply damage from a bullet or any source in the game. We just call the take bullet damage, and then it will determine if it should call lethal damage or non-lethal damage functions, and then it'll also decrease from the current health. The current health, on lethal damage, and on non-lethal damage can all be customized inside of child enemy pawns. So if you were to create your own custom enemy pawn, like I have the turtle enemy pawn for example, you could override the on lethal, on non-lethal, and current health fields to do custom things for that specific enemy. The compute spawn value function is going to be used in the future to determine where we want to spawn certain creatures, but I'm not going to cover that in this video. So the enemy pawn mainly takes care of health and enemy life cycle. So to create a new enemy, we have to create a child class for the enemy pawn, and then that enemy pawn child will represent the enemy. We can then assign certain fields like the mesh, the skeletal mesh, and assign animation blueprints in that enemy pawn, as well as attach a unique utility AI component. The utility AI component I made for this game is, I guess it's quite unique, and it has its own set of rules and functionalities that really will define the game and help give the player certain patterns to look out for to help defeat and have fun with the enemies. So you may be wondering now, what is utility AI? The most general way to describe a utility AI system is that it is an AI system that chooses the highest utility for any given behavior, or chooses the one that has the highest value for the enemy or AI. So what does that really mean? That means that there's a set of different behaviors that an AI can do. So for example, you could run, jump, heal, or an attack. And for each of the different actions or behaviors that the AI can do, you assign a value or a utility to it. And at the end, you want to choose the action that gets the most utility or has the highest value. So in the example you can see I'm doing on the screen, this utility AI can jump, attack small, attack big, heal, and run. Let's then say that there's always a 0.5 value to jumping, so that's like the baseline. Also, the utility AI will have access to the world, so it can ask all kinds of questions to the world to determine what it wants to do. So for example, it can look at the player and see if the player is attacking and use that to determine if it wants to run. So the player is attacking, so let's say 0.6 value to run. And then it can look at itself and see if it's low HP, and if it is, it can assign a higher value to healing. So let's say 0.8 for healing since it's low HP. It can also check and see like if its attack's on cooldown, and if it is, then it can assign a 0 value to doing that attack, so it will never do it because it'll have such a low value. Let's say its small attack is its basic attack, so we always assign a really high value of 0.9. So that means that it'll always attack small when it's close to the character, but once its health gets lower and the healing value goes up, it'll start healing because the heal will get higher than the 0.9 of the small attack. So this system seems great and all, but that example is still pretty basic, and if we make every enemy from scratch with a fresh utility AI component, it'll end up being a lot of extra work for what I needed in this game. You can kind of think of this as a general rule of programming or structure design, but the more rules or restrictions we add to the system, the more easy and quick it'll be to define new members of that system. And usually it also makes it a lot more fun to create members because you have to think of different ways to work around the restrictions you've made and the weird interactions you didn't expect it to create. So next is to think about what restrictions we'd like to apply on the utility AI component in order to make it a lot easier and efficient to make new enemies. The first restriction I made was that I broke up actions into 3 separate different classes. So there's movement actions, active duties, and passive duties. A movement is just a way that the enemy can move itself. So for example, there can be a swim action or a flying movement action that will control the enemy in a flying or swimming manner. The active duties are certain attacks or heals or anything that can really have a cooldown that the enemy actually has to actively do. And the passive duties is considered to be anything that the enemy will do while it's not doing an active duty. So for instance, wandering around randomly or circling the player. We then have the utility AI component going through 2 different loops at different frequencies to determine what the AI should be doing at any given point. The first loop is the move loop. The first thing it'll do, it'll compute the max value movement action. So that'll basically be to determine if the enemy should swim or fly to a certain point. It'll then use the get go to location from your current duty. So whether it be an active or passive duty that you're currently doing or the AI is currently doing, it will use the movement. So the first 2 steps basically use the movement action to go to the location the active or passive duty needs the AI to be. And then third, if it's doing an active duty and it can do the active duty, as in it's at the location it needs to be, or whatever criterion you set, then it will actually do the active duty. And then it'll repeat from the beginning. The other loop is the compute duties loop, which is less frequent than the move loop because we need to change what the actor or enemy is doing at less frequent intervals than move it. The first thing that the compute duties loop will do is it'll see if it's still performing an active duty. So let's say that the move hasn't finished yet. And if it is still performing the active duty, then it wants to stop computing because it doesn't want to overwrite the active duty that it's still doing. So it'll just keep repeating until it's not doing an active duty at step 1, and then it'll eventually get to step 2, which first checks if it can do an active duty by seeing if the cooldown is up. And if it can perform another active duty, then it will compute the max value active duty and start it. And if it can't, then it'll just compute the max value passive duty and then start that one. It will then just repeat back at the top starting at 1 and repeat the process of making decisions. That'll be it for the intro into utility AI, and that'll also conclude this video. Like and subscribe if you enjoyed or you feel like you learned something. Also stay tuned because in the next video we'll actually be implementing this in code and demonstrating how it works with a couple enemies. You may notice that there's still a lot in the game that I haven't covered in this devlog series yet, but to tell the truth, we're very rapidly catching up to where I am in the game. So I've decided to start releasing content that is also outside of this game. So for example, I'm releasing videos about my Wind Waker VR project now. You can actually go check out the first episode on my channel. I think you guys would enjoy it. I'm recreating Wind Waker in VR to have native VR controls and really make the player feel like they are Link when they're playing the game. I might even start doing some more series or maybe even tutorials for UE4 or other game dev things. So let me know if you guys have any questions and maybe I can help. I am still kind of new though to UE4 and game dev, so I wouldn't put the most hope in me being able to answer your questions. Thanks again for watching. Magic Turtle out.